Okay, this section is all about solving formulas and variation. The goals, number 1, we want to solve formulas for a specified variable, which is going to help us with goal number 2, to solve variation applications. So first, let's back up a little bit. When it comes to solving equations, there's 2 main principles you need to know about when solving equations. The first one I call the reversibility principle. So the reversibility principle basically says that any operation you perform in math, what are operations? Really familiar operations? Like, I'll give you one: addition, subtraction, multiplication, division. There are others we think of as, they're actually functions, but we think of them as operations like square rooting and squaring, right? So what the reversibility principle says is any operation in math can be undone by doing the reverse or inverse operation. So if you want to reverse adding 2 to a number, what do? You subtract 2. If you want to reverse multiplying by 8, what do? Divide by 8. And if you want to reverse subtracting 1.2, you add 1.2. This is not a new idea, right? Not at all. And then if you're solving an equation, what do you think the balance principle might say? Whatever operation you do to one side, do to the other. Any operation on one side of an equation must be done to the other side of an equation to keep the solutions the same. That's the balance principle. So I want you to keep these 2 principles in mind when we go through solving formulas for specified variables, because all we're doing is solving equations just like we've done in the past. They just don't look as pretty as they looked previously. In this first example, we're going to solve for the specified variable. So notice it looks like we have w divided by itself, right? No. When you're dealing with equations in, say, physics or chemistry, a capital, an uppercase letter is different from a lowercase letter. So it's hard to tell the difference with my w's, but you see the w on top is bigger than the w on the bottom. That's a capital or uppercase W on top, lowercase w on the bottom. Those are different letters. We consider them case sensitive, put it that way, right? Different letters. And then same thing on the other side, uppercase D, capital D divided by lowercase d, different letters. So you can't say, otherwise you get 1 equals 1, right? That's a stupid equation. So yeah, the uppercase different from lowercase. So after the semicolon comes the W. You're being told to solve for W here. So how do we get uppercase W by itself? What are we doing to it, first of all? On the left side, what are we doing to uppercase W? We are dividing uppercase W by lowercase w, right? So how do we undo that division? How do we reverse that division? Oh, reversibility. We can multiply by w, lowercase w, right? To get rid of that w in the denominator. You've seen this idea before. So we're going to multiply by little w. To get w by itself, to reverse the division by little w. But balance principle says you have to do what to both sides? Yeah, apply that multiplication of w to both sides. So there you go. There's the 2 principles right away. Reversibility and balance. So on the left side, you can see what's going to happen. Little w divides with little w. We're left with just what we want. Uppercase W. That's the left side. How do you want to write the right side? Well, you can think of it as little w over 1 that you're multiplying by, right? So if you multiply straight across, what do you get? Yeah, capital W times, or capital D times lowercase w over lowercase d. Resist the urge to cross out the d's because they're not the same. There you go. So a very simple example you probably could have figured out on your own. But I wanted to really show you a simple example in the context of reversibility and balance principle. So solving a formula for a specified variable. A formula is just an equation, right? So by the way, the idea is what we're doing here is we're thinking of like uppercase W as the unknown. The lowercase w, the d's, we're thinking of those as just numbers, right? And if you do it that way, the properties you've learned, the techniques you've learned for solving equations are the same as always.